Hi everyone, we are going to work on 7.3 notes, general sinusoidal graph. We're going to learn how to graph two complete cycles of a sinusoidal function. Y equal to C plus A sine or cosine of B theta minus D is the general form of a sinusoidal function. Now we're going to learn what does each of these letters mean. The A value that you see here is a number that is multiplied by your function outside of that. This is going to define the amplitude of the function. That means vertical compression or stretch. The B value is horizontal compression or stretch. It's going to define the period of the function. So we can find period of the function using this B value. If the function is in degrees, to find the period, you need to divide 360 by this B value. Or if the function is in radian, you divide 2 pi, which is the period of the parent function in radian, divide that by the B value. That's going to give you the period of the current function. C value is vertical shift. So it's going to define if your function is going to move up or down. So this is vertical shift. And the D value is the horizontal shift. The D value can move your function to the left or right. We also call that phase shift. We call this as phase shift. That means if you're adding a number, let's say pi over 6 to your theta, this is going to move your function to the left. But if you are subtracting, it's going to move your function to the right. So this is left, this is right. Vertical shift, if the number that you're adding to function is positive, it's going to move it up. But if the value of the number that you're adding to function is negative, then it's going to move your function down. So for example, if I have -3 plus sine of theta, this is moved down. If I have +4 plus sine of theta, this is moving up. But this number could be also written on the right side at the end of the function. That means you could also write that as sine of theta -3 or sine of theta +4. So you see, it's a number that is added or subtracted to your function. If it's subtraction, moves down. If it's addition, moves up. Now, also, if you have a negative behind your function right here, instead of this plus, if you have a negative value, that means there is a reflection over x-axis. So your function is reflected. Okay, so let's practice that here on this example. This problem is the same thing that you can see on your homework. That's the first question of the homework. So I have copied that here to practice that together. What you see here is all the steps that you need to take in order to be able to graph this function. So if you follow these steps, you will be able to graph your function completely. So the suggested order is to make a sketch of the curve. So first of all, if I have a cosine, how would the cosine function look like? I'm going to draw a small sketch of that. I know that cosine, parent cosine looks like this. Starts with a high point. Now we're going to draw the axis of symmetry. First of all, I'm going to draw the coordinate plane. Axis of symmetry here is 7 because your function is moved up 7. That means the sinusoidal axis, which is axis of symmetry of the function, is moved up 7. So I'm going to draw a dotted line here as the sinusoidal axis around this point. Let's say this is the sinusoidal axis, which is at y equal to 7. The amplitude of the function comes from 4. This is the period of the function, and this is horizontal shift. Anyway, so we're going to find maximum and minimum of the y-axis. How do I find that? By looking at the amplitude of the function. Amplitude is 4 here. That means from the sinusoidal axis, we need to go 4 up to reach to the highest point or maximum point. So that's going to be at 11. And 4 down, around here, maybe 3 is the lowest value of the function. So we found maximum and minimum on the y-axis. Then we need to find the horizontal shift. Starting point on the x-axis, that's the horizontal shift. It comes from this value. This is the horizontal shift. As you see, we have theta minus 10. That means the function is moved right 10. Although I have negative, but this is going to move right 10. So this is the first point at 10. Then we need to calculate the period of the function using either of these two formulas, depending on if you have a degrees, function in degrees or radians. So this is in degrees, so that means we're going to use this one. The b value is this one. Number 3 is the b value. So the period of the function will be 360 divided by 3, which is 120. So this is the period of the function. Then divide each period into 4 to label the rest of the x-axis. That means we want to find the rest of the x-axis, the critical points. So divide 120 by 4, that's 30. This is the steps between the critical points. That means from each critical point, I need to go 30 forward to get to the next one. So if the first point is at 10, the next one will be 10 plus 30. Let's say here, this is the next critical point. Then plus 30, 70, plus 30 is 100. I need one more because in one cycle, we have 5 critical points. You see high point, low point, I'm sorry, midpoint, low, mid, and high. There are 5 points in one cycle. So the next one will be here 130. Okay, now we can draw the, start graphing the curve of the function. Since this is a cosine function, we start with a high point. The first critical point is at 10. So the high point is here. The next one is a midpoint. Then we have a low point, mid, and then high point. So this is one cycle of the graph. If you want to graph 2 periods, then you have to continue moving forward another 30, another 30, another one at 220, and another one that should be at 250. Then again, high, mid, low, mid, and high. So this will be the next period of the function. Now let's work on question number 4, which is in radian. So we're going to follow the same steps. First, I'm going to graph the coordinate plane. The general sketch of the graph is again cosine, so up, middle, down, high. This is the general form of the function. We're going to follow the same pattern basically. Okay, now what was the first step here that we talked about? The first step was sketch a graph, sketch the curve basically, then draw the axis of symmetry. So we're going to draw the axis of symmetry here. We're going to get that from the value that you see here, 2, this is the vertical shift up or down. This is going to find the, oh, I'm sorry, it's question number 4. So it's right here. So come from the C value, which is moving the function 23 up. So I'm going to start with graphing the sinusoidal axis or horizontal midline of the function. Let's say this is 23. Okay, now let's go and see what is the next step. The next step is find the maximum and minimum of the y-axis. So to find the max and min, we need to find the amplitude of the function, which is coming from here. Amplitude comes from the a value, which is 30. So that means from here, we need to go 30 up, which is at 53, and 30 down, which is at -7. So that's the highest point, and this one is the lowest point. I'm going to bring this a little bit more down so the y equal to 23 is almost in the middle. Okay, this looks better now. So we found the maximum and minimum point. Now, what is the next step again? We want to find the horizontal shift. Okay, let's go and see what is the horizontal shift here. Minus pi. That means the function is moved pi to the right. So that's the d value, which is pi. That's moved right. Moves the function right for pi radians. So let's say pi is here at this point. Okay, the next thing that we need to find is the period of the function using 2 pi divided by b, because this function is in radian. Okay, so period of the function is 2 pi divided by b value, which is 1/5. 1/5. How do I calculate this? Keep, change, and flip. So keep the top, change the division to multiple, and flip the bottom. So this will be 10 pi. Okay, so 10 pi is the one period of the function. Okay. Next, we need to find the critical points, the steps between the critical points. We need to divide each period into fourths and label the rest of the axis. So I'm going to go here and divide the 10 pi by 4. I can simplify this. 10 divided by 2 is 8. Oh, I'm sorry. 10 divided by 2 is 5. And 4 divided by 2 is 2. So this is 5 pi over 2. These are the steps between the critical points. Okay, now we're almost close to be able to graph the function. We're going to draw the two labels. How? By finding the critical points from here, by finding the steps, using the steps to find the next critical points. Okay, so the first point is pi. The next one will be pi plus 5 pi over 2. How do I find this? The denominator here is 1. So you're going to multiply by 2, top and the bottom by 2 to get the same denominator, because we need the common denominator. The first one will be 2 pi. The denominator is 2. Second was already 5 pi over 2. So this is 7 pi over 2. So the next critical point is at 7 pi over 2. The next one, what is the next one? We're going to add 5 pi over 2 to the previous one. So this plus 5 pi over 2. That's going to be 12 pi over 2. You can simplify this as pi over 6, or you can just keep it as 12 pi over 2. It just makes the calculations a little bit easier. And then add another one, 5 pi over 2. That's 17 pi over 2. That's the next critical point, 17 pi over 2. And we need one more plus another 5 pi over 2. That's going to be 21 pi over 2. Oh, I'm sorry, not 21. It's going to be 22 pi over 2. Okay, so here, 22 pi over 2. As I said, you may simplify this, like 22 pi over 2 is equal to 11 pi, because 22 on top and the bottom could be simplified by 2, but I'm just going to keep them the same way, and it's fine. So we're ready to graph the function. We know that the cosine starts from high point, so the first one is high point, then we have a midpoint, then low point, mid, and high point. So this is the first cycle. And if you want to graph the second cycle, you can just go forward and find the other critical points and graph the function. Okay, now let's work on question number 7 together. Here, I'm going to start with graphing the coordinate plane. Okay. Then we're going to start with finding the horizontal midline or sinusoidal axis. That's coming from the 8 value that we see here. That means the function is moved up 8. So the horizontal midline of the function is here at 8. At y equal to 8. Then we need to find maximum and minimum point, which is coming from this a value, which is equal to 10. So we go 10 up at 18 and 10 down, which is at -2. That's going to be the lowest point of the function, maximum and minimum point. Then we need to find the period of the function. Period of the function comes from dividing 360, because we work with radian, by the b value, which is 9. 360 divided by 9 is 40. So 40 is one period of the function. Then we need to find the steps between the critical points and find the critical points. Then we're going to divide 40 by 4, which is 10. So these are the steps between the critical points. Now I'm going to find the horizontal shift, the starting point. This is x plus 15. That means the function is moved left 15. If you have noticed, I calculated the period first, then I did the horizontal shift. The steps was saying that do the horizontal shift first, then the critical points and the period of the function. It doesn't really matter. That was just a suggested order. You could do either of them first. Anyway, so the function is moved left 15. That means from the 0, you're going to move 15 left. So at -15 is the start point of your function. Now, we need to find the next critical points. The steps are 10. So from -15, you move 10 to the right. Here at -5 is the next critical point. The next one plus 10 will be at 5 is the next critical point. Plus 10 is 15, next one, and plus 10 at 20 is the next critical point. Now we're ready to graph the function. However, we see that there is a negative here. That means the function is reflected over x-axis. The general form of sine, the sketch of the sine function looks like this. Starts from the midpoint, goes up, mid, low, and then midpoint again. So this is sine function. But since the function is reflected, so it needs to be this way, reflected over x-axis. So it's middle, low, middle, high, and middle. So we're going to follow the same thing. We start with middle point, then we have a low point, then midpoint, then we have a high point, and then middle point. So this is the graph, which is also reflected. I hope this was helpful for you all. Have a great day.